Hi there. My name is Kent Bai, and I usually do a VR podcast, but today I'm going to be getting into the physics of UAP, and I'm here with Matthew. Matthew, maybe just could quickly introduce yourself.
Sure, I'm an associate professor of physics at the University at Albany, part of the SUNY system, State University of New York.
Okay, great. Well, I just wanted to set a little bit of context because, this is a bit of a new topic for me to be covering since I usually covering emerging technologies, but I'm just going to quickly share my screen here. So I've always really been interested in the UFO topic. In fact, I watched Tom DeLonge's To the Stars Academy press conference in October, and I saw a YouTube video, and then I saw Grant Cameron's sort of follow-on video saying, "Hey, Tom DeLonge's the real deal." And then the New York Times article came out, and all the stuff that I've been looking at for years and years and years in this sort of esoteric UFO community was kind of crossing the chasm into the mainstream. And I thought this was a fascinating story, and I've been tracking it pretty closely for the last 41 months on my Twitter stream as the news has been coming out and more journalists have been doing different levels of verification. And yeah, I guess there was a parts of the story that I've been tracking personally. Part of it for me that's interesting is the philosophical implications. Like, is this real? What are the new paradigms that we get from this? What are the scientific implications? Because I think there's actually quite a lot of science that Hal Puthoff was actually shown at the very beginning, at the very start of this. So Hal was actually introduced at the To the Stars Academy introduction that happened back in I think October 17th of 2017. Tom DeLonge actually showed some physics equations in this press conference with the Alcubierre Warp Drive. And then he sort of does it's sort of a mashup of all these different equations. And then I went through and found that this was a paper from Hal Puthoff, and that's since been cited a number of different times. And then, the Alcubierre's warp drive faster than, the hyper fast speeds. So relativistically, you can see as something is going faster than the speed of light, but it's actually not. It's just sort of like a perceptual illusion. We can get into this sort of warping of space-time. But anyway, I wanted to have Matthew on because we were just at this conference called the Scientific Coalition for UAP Studies. It's a bunch of different scientists who are looking at this issue of UFOs and UAP. And they had a whole conference called the Virtual SCU Anomalous Aerospace Phenomena Conference, AAPC, that happened from June 5th to 6th. And so I've been interested in this. I attended it. And Matthew, you had a really amazing presentation that you had there. But maybe I'll sort of hand it over to you now in terms of how did you end up at this conference and how did you get into this whole field?
Well, it's really due to my good friend Kevin Knuth, who was also there. He has one of the panels. He's one of my colleagues. He's a fellow professor at the University of Albany. And his passion and interest in this area is what really originally drew me in.
Okay. And so whenever I look, so Hal Puthoff, as I said, that there's this sort of physics equations and math that he was proposing that the Alcubierre warp drive is if you have exotic matter or negative energy density, you could actually have this sort of faster than light travel, or at least be able to travel great distances. Whenever I hear a lot of the mainstream scientists and astrophysicists, they're kind of well, it would violate the laws of physics. It would take too much time for things to actually travel here. And I feel like there's actually some advanced theoretical physics out there that says that's actually possible. And so from a physics perspective, I'm curious how you sort of got into this question, because what I hear from a lot of the mainstream physicists is oh, it's impossible that they could ever get here. And that seems to be a pretty big thing, stopping a lot of scientists from even looking at this as an issue.
I consider that complete rubbish, and I'll explain why. It's twofold, actually. And half of the answer is FTL, but half of the answer requires no new physics at all. And so so I think it's complete. I disagree with many of my colleagues. I think it's complete nonsense to claim, it's too far away, interstellar travel is too hard. So I want to attack it first from the conventional physics perspective. So let's set aside FTL because it is more speculative. So one thing that my friend Kevin, who I just mentioned, always points out, you don't need FTL to explore the universe because time dilation works in your favor. You don't need any new physics. So I always give this as a homework problem to my students. For example, we like to think, Andromeda Galaxy, 2 million light years away. That would take 2 million years. Wrong. If you travel just 0.1 meters per second slower than the speed of light, you can get there in 50 years. Sure, 2 million years will have elapsed on Earth, but not for you. And so time dilation works in your favor. So relativistic time dilation means you can explore the universe as long as you don't care about going back home, like your relatives' descendants are long dead, but you can explore the universe without any need for speculative, faster than light, this, that. And I just don't understand how many physicists forget that and say, oh, they'll never get here. It's too far. It takes too much time. It does not take too much time, because you can cross the entire Milky Way galaxy in months or weeks or years, not thousands of years. Now, the counter argument to that is always about, oh, what about shielding, radiation, and all the ill effects of relativistic space travel? But I like to point people then to the critics who once said air travel would never be possible. Very learned physicists and mathematicians said air travel was a joke. It would never be possible. Many people said space travel. There was an astronomer 2 weeks before the launch of Sputnik who said space travel, that's never happening. And so, like, if you look at the history of science, all these things that were claimed to be impossible were impossible not because they break the laws of physics, but because we didn't have the imagination yet as engineers to find engineering workarounds within the laws of physics. And so that's the first half of my answer is you don't know the FTL, so it's complete nonsense, in my opinion, in my scientific opinion. So it's not just an uninformed opinion. In my scientific opinion, it's utter nonsense to claim that, oh, it would take too long. You don't even need FTL.
So I want to dig into this whole phrase of the laws of physics, because my understanding of the philosophy of science is that, you know, we have certain paradigms, and then you have that you can never really prove something to be absolutely true. It's only like it's true until it gets falsified or proven wrong. But there's certain things about physics that seem to be pretty solid, but yet I sort of reject or I resist hearing about the laws of physics, because, like, well, it's a model and the model could be wrong. But I'd say the other thing that I when looking at this very specific issue of UAP, it seems like something like the Alcubierre Warp Drive, it takes an assumption of either exotic mass or negative energy density in order to, like, you know, get some of this stuff to actually work. So either, you know, the laws or we can sort of say that they're laws and they actually stand, or there's certain things about the laws that we misunderstand, and it's sort of, we have a new paradigm that we have to sort of shift with this anomalous information that's coming in. Kuhn talked about the structure of scientific revolutions. That was all about having models, and then you have anomalous information. And usually you reject the anomalous information if you don't have enough of it. You just sort of discount it. But once it reaches a critical mass of anomalous information, then that anomalous information has to show that there's a model drift that happens. You have to have new models. And then you have new paradigms that come in once you're able to have new models that actually are able to accommodate the previous information, but also the new information. So I see this kind of like paradigm evolution of science in itself, and this unfolding process. So at some level, I'm resistant to this kind of, you know, what Alfred North Whitehead would say is like this sort of misplaced concreteness, putting the abstractions of the math as above and beyond what the observed evidence might be. When in reality, you have to sort of, it's a give and take between those. But I'm curious to hear your thoughts on that in terms of both the laws of physics, but also kind of like some of the assumptions or new ideas that are coming up based upon some of the evidence that at least you're seeing.
Yeah, well, like I said, I had two halves of my answer. Second half is really that, yeah, you don't even need to change things that much for something like a warp drive to be possible. It's been many years since Miguel Alcubierre's original paper. It's not just Hal and Eric Davis, one of his collaborators. Many others have been working on this and chipping away and showing, oh, that impossible thing is not impossible within the known workings, without having to do any paradigm shift yet, have been able to chip away at many of the aspects. So don't get me wrong, I'm very excited about the possibility of faster than light travel that requires none of the time dilation I was just saying. I was just giving you the first half of my answer as like the conservative answer, in the sense that you don't even need a paradigm shift to explain at least some fraction of the phenomenon or of interstellar travel, extraterrestrial civilizations. You don't even require a paradigm shift in some ways. But absolutely, I think I have been increasingly convinced, it's not my work directly, but I've been increasingly convinced that we're going to chip away at what seem like the impossibilities for faster than light. And I'm getting increasingly convinced that that is a separate and a second viable option in contrast to what I just said earlier. Now, in terms of laws of physics and paradigm shifts, there's something I always teach my students. I think this might be, I have sort of my own sort of personal philosophy on this, and I don't think it fully agrees with Whitehead's view of things, but I think that paradigm shifts are changing in nature. And that's because centuries ago, we didn't have microscopes, telescopes, blah, blah, blah. It was much easier to be wrong. We just, shooting from the hip. The way I look at things now, and you're right, while you're technically right that we can never prove something, only disprove, but there, like you said, there are things that are pretty solid. I mentioned this in the conference. We're not going to wake up tomorrow and find out Einstein is wrong or GR is wrong, quantum mechanics is wrong. That's impossible because our phone wouldn't work. The computers we're using wouldn't work. It's not possible anymore. So the way that shifts work now, actually more recently, is we're finding deeper levels of approximations of reality, but you don't throw away the earlier ones. A good example of this is people like, oh, why do we teach Newton? Einstein showed Newtonian mechanics was wrong. That's the wrong way of thinking about it. It's not like there was a paradigm shift and Newton was wrong. I disagree with that philosophical approach to the history of science because Newtonian mechanics is good enough to get you to the moon. You don't need general relativity. Okay, you need general relativity for a tiny correction, for example, to Mercury's orbit. So the way that paradigm shifts have worked more recently are different than they worked centuries ago. Like, heliocentrism didn't improve geocentrism. It chucked it. It was wrong. But more recently, as our technology has improved, the way I like to think about it, and I know it's a very controversial statement, easy to disagree with, it's getting harder to be wrong as our technology improves. That doesn't mean there's not going to be another paradigm shift. Don't get me wrong. We have to be humble. And I'm not saying there won't be another paradigm shift, but there's no way there'll be a paradigm shift that shows general relativity is wrong, because then your GPS wouldn't work, but it does. And so technology means there are certain theories that doesn't prove they're right. I'm not disagreeing with you. All this means is general relativity, quantum mechanics. It means that instead of being wrong, like ancient theories were like geocentrism, it means they're incomplete. And I said this during the conference, there's a big difference between wrong and incomplete.
Yeah, I guess where I'm coming from in that is when I hear scientists in the mainstream say, because of our laws of physics, and that this violates our understanding of those laws of physics, this can't be true. And it seems to be like that's a bad argument because the laws, there may be information that is, like you said, there's incomplete aspects of it, given like assumptions like negative energy densities or exotic masses that are shifting our direct experience of what we can experience with those, our empirical way of being able to test that. And I think this gets into an issue that I've seen again and again and again with this issue in terms of the scientific perspective, which is that there's a lack of data. And most of the data that are available is classified with highly, the radars and all the different sources and methods that come from the US military. There's apparently lots of information and data that I would love for the scientists to have access to, but yet it's so highly classified and there's so many national security things about and taboos and stigma. That's a whole other thing. But those things two combined has created a situation where it's really difficult for the scientific community to be engaged into this topic because there's a poverty of data. There's no evidence to be able to say, here's the provenance for this data. Here's the multiple sensors that we have all this. We're going to put it out into the academic community and we're going to let people take a look at it and make the most sense of it. That stuff has been happening within our intelligence community, within special access programs and unacknowledged special access programs and waived special access programs, top secret, special compartmentalized information type of data. It's like that's alleged. That's what they're alleging. But I'm just curious to hear from your perspective as an outside scientist, this dynamic of the data and the lack of data and how that impacts the rest of the scientific community.
Yeah, part of it is a tautology. So part of it is circular. There is the issue of classified data, but there's another problem, which is that the scientific community has decided it's nonsense. Why is it nonsense? Because there's no data. Why is there no data? Because it's nonsense and you're not allowed to collect the data. And no one sees the problem with this. Neil deGrasse Tyson and everybody, no one sees the problem with this circularity here. And so that's what convinced me finally, joining with Kevin, it's time to break the circle of ignorance. Part of that is classification, like you said, at high levels of government, if that's true, of course. But even separate from the issue of government and classified data is the fact that you're not allowed to study it because it's crap. Why is it crap? Because you're not allowed to collect the data. And round the circle of nonsense goes, and scientists are not allowed to do their job. And as a result, there's all the metaphysical and mythological layers that get added to the phenomenon. And then that creates a vicious negative cycle that turns scientists off, because then UFOs get buried with all the woo-woo and the mystical stuff. And then any real data gets buried on all those levels.
Yeah, well, I know we had a chance to have some networking sessions and talk briefly about the I guess the stigma and the taboo around this. And I'd love to hear your perspective on, you're someone who's a mainstream academic at University of Albany, teaching physics and doing research into dark matter, dark energy. We can get into that in some of the stuff that you're presenting. But you're somebody who's got an academic career, but yet this could be seen as something that could be damaging to your professional career, to be involved with something like UFOs or the unidentified aerial phenomena. But yet there's something about the scientific curiosity or something that you're willing to be able to kind of step in past that stigma and through the taboos to be able to get more directly involved. And so I'm just curious to hear about your own journey and experience through the stigma of this topic, as well as some of those taboos.
Well, I think my first answer will make your listeners laugh. It's one word. It's called tenure. I can't get fired, so I really don't care about that. Well, if it damages my career, maybe I won't make it to full professor, but you know what? I don't care, because the way I look at it, Ken, is that if there is some truth to claims of whatever it is, unknown new phenomenon, is it extraterrestrial or something that this could potentially be the greatest discovery in human history. Why isn't that worth some risk of pushing back against a silly taboo when this could be the most important discovery ever, period? That, like you said, could cause paradigm shifts in our understanding of physics, chemistry, biology, everything. Isn't that worth the risk? And also the other way I look at it is I'm not dropping everything. I've still got my main focus on dark matter is going to take up most of my time. And so I'm not dropping everything and devoting the rest of my life, including my academic life, to it either. Because what if it is all wrong? I don't think that's the case. But what if it is all whatever, optical illusions, whatever? I don't buy that. But I'm not putting all my eggs in one basket and selling the farm, and the proverbial and all those ever. So I think that's my multifaceted answer. But the most important thing is really, there's a lot of arguments about this in on the internet about the benefits of our academic system. And seriously, tenure is one of the foundations of being able to take risky ventures. There's another aspect to it, which is the government has funding for it. Money is green, right? The university's not going to care. It's just, money makes the world go round. So if we can get funding to do UFO research, you think the university is going to care? All universities in the country are experiencing budget crises due to COVID-19 and the pandemic. No one's going to care where the money comes from if the university is getting money. So I know that's kind of a cynical answer, but I'm giving you the honest answer, my honest answer.
So I'd love to hear about your own personal journey into this as a topic, because, in December of 2017 is when I think it definitely shifted from something that was in the realm of conspiracy theory and unverified stuff into being verified by the New York Times and that article that came out on December 16th and on the online digital edition, and then December 17th on the print edition. And then also Politico and Brian Bender also did a piece. So it sort of had this shift, and there's since been a lot more reporting with former CIA directors and former director of national intelligences coming out, and President Obama. I mean, it's sort of like it's gone from being totally delegitimized into something that it's like almost totally mainstream. But where did you enter into this the last number of years, or when did you enter into this story of the UAP?
Yeah, so that it all begins with so I knew from a very young age that at first I wanted to be an astronomer. That got modified over time, astrophysicist, physicist. But I would watch Star Trek Next Generation, as I mentioned, in my talk and during the conference. And even though that's fiction, that did help. It sort of like acculturated me to the idea that, oh yeah, aliens are real. We just haven't found them yet. So even though that's fictional, that kind of though plants that seed. There are also books I read, because I read books by the big particle physicists like Leon Lederman and books by Michio Kaku and people like that, Kip Thorne. But I also I loved reading books about the UFO phenomenon. I can't pinpoint, because I was literally, I can't pinpoint an exact experience and tell you the story of the day that I just realized that this was interesting. I can't, unfortunately, pinpoint an exact moment like that. But it was more of a slow process where it didn't seem initially to me, at least when I was younger, some aspects of it at least did not really seem very pseudoscientific or wrong at all, but rather it did seem perhaps unfairly stigmatized, because even when I was a kid, we still had, I actually don't remember if he was still alive or I was just reading his books. There was J. Allen Hynek, who was a real scientist, things like that. So there were real scientists slowly, trying to look into things even when the taboo was still strong. And I don't just read science, I read of history of science. And I couldn't help but look at some parallels. So let's say that it turns out this is an interesting new phenomenon, interstellar spacecraft or something, and it is really important and new. I couldn't help but realize that one time, we laughed at germs. Germs, little tiny things. What complete nonsense. Or atoms. We used to laugh, oh, atoms, there's no such thing as atoms, or it's a mathematical tool. They don't really exist. And I feel like through the history of science, there are these ideas that initially like, oh, what a crazy idea. And the vast majority of the scientific community thinks it's nonsense. But here's the thing. Nature doesn't care about a consensus. Nature doesn't care if the majority of human scientific community thinks something is right or wrong. Truth is not by consensus. Truth is not a democracy. Truth is not by majority. So to me, I looked at all these instances in the history of science where Einstein is another good example. Relativity was initially considered nonsense, and it was almost, there was, a racist element. In Germany, Einstein's work was considered Jewish physics. And in the UK, it was considered German physics, because it's after World War I. Germans weren't exactly very best friends in the United Kingdom. So I see these examples where things go from, sometimes even in one generation, from treated as nonsense to like, oh yeah, that's physics. Einstein is right, and everyone who disagrees with him is wrong, and it's just a flip. Sometimes even within the same generation.
Yeah, and so for me, what gets me excited about this topic is that it's going to have a new, totally on board in terms of, if this is true, this is like the biggest story of the history of humanity. So like, it seems like potentially high risk, but a high payoff type of thing to dive into. And I think as we move forward, we need more data. We need more of the scientific process, because there's a quote from Agnes Callard, who she talks about like the dialectical process of truth, where there's those who believe and those who you can either preference believing something or avoiding falsehoods. And so you put forth hypotheses and you gather some data, but then the scientific peer review process is the one that maybe is preferencing avoiding falsehoods, and they try to critically analyze it through the peer review process. But it's sort of a dialectical process between those who believe and those who are more skeptical and trying to avoid the falsehoods. And that science is actually dialectical collaboration between both of those sides, having the will to believe, but also having the skepticism to be able to actually, put it through its paces. And that's how knowledge progresses. But when one side or the other gets too much power, and if something, it's like, we're not even going to consider this because we don't have any will to believe, then I think it can prevent progress from happening. And I think that to some extent is what's happening. But at the same time, there hasn't been verifiable data that has been able to, it's like been more phenomenological experiences or these little encounters, but not like there's been a repository of data that's been open data that people have been able to have access to. So that's sort of where I see this as the larger context of the scientific community, where it is very exciting, but it's also, I think we're at the stage where this is where I'd love to hear a little bit more context. As you've entered into this phase, you kind of go through and you're trying to like navigate what is a giant rabbit hole of all these potential, like, I know there's like researchers like Richard Dolan who have said that there's like 16 levels of disclosure, in terms of how far the rabbit hole goes, in terms of how far of the conspiracy goes into, so many different levels. And I think we're still at the very early phases of just like saying, okay, this seems to be a legitimate phenomena. And what is it? But, as you've been digging into it and trying to look at, this whole layer of published literature, but also there's the classified literature and people who have had ways to kind of go in between those, people like Hal Puthoff and Eric Davis, who have been involved in both the science aspects of publishing papers and theoretical aspects of it, but also getting access to a lot of privileged information that they're not at liberty to be able to talk about. So I'm curious how you've been able to start to interface with this this nuance of, based upon what your own interests are, research interest, and trying to get at least some maybe insider information, or having some of these discussions and dialogues from a scientific perspective in terms of what may be helping push your own research forward.
So I've always tried to be kind of, I would say, a centrist. So I really like this dialectical collaboration that you're mentioning. I think it's extremely important to balance skepticism and open-mindedness. And I think that most scientists think science is only about skepticism. If that was true, then again, germs, atoms are absurd ideas on their face, right? These tiny things we can't see that make us sick, or things that make up everything. These are, in their time, they were absurd ideas on their face. So I think it's important to always balance skepticism with open-mindedness. And both extremes are dangerous. Open-mindedness, we're like, everything is true. You believe every eyewitness testimony of every alien abduction and this, that. You can't do that. But you also can't go become a debunker, because then you might miss the greatest discoveries of the century or human history, because you're like, oh, it's nonsense, so I won't even bother looking at the data. So when you're on that end of the spectrum, you end up, even as a scientist, being almost religiously passionate, and you become almost no better. I know both Avi Loeb and Kevin Knuth have said this. You become no better than the cardinals and bishops who refuse to look through Galileo's telescope. Some of the debunkers, like Navy Tic Tac video, remind me of the bishops and cardinals who said, oh, Jupiter's moons, those are just optical artifacts in your telescope. That's not real. And so I can't help but draw parallels between those in the scientific community who've taken the extreme of skepticism. But I don't think I fully answered your question.
Oh, well, that's a good start. I think the thing I was sort of wondering is that, as you've, from your perspective, you're starting to interface with some of these, I mean, you're trying to get the lay of the land of this, and look at some of the different theoretical work, but also perhaps, engage in some conversations with people that have looked at this. And so as you are kind of getting ramped up, I think that in your talk at the Anomalous Aerospace Phenomena Conference, you were sharing very specific things around your specific research around dark matter. And there was something that Hal Puthoff was talking about, like these metamaterials that are more speculative. We don't know what their purpose is, but there was some aspects of some of the potential ways in which that these were manufactured that was at a certain wavelength frequency that was resonating with your own research. And so you start to kind of reach out and have these dialogues and connecting these dots between something that is very exotic in terms of metamaterials and UAP, but you yourself are trying to find something that no one has evidence for. So you're in a state of being open-minded of this inquiry of trying to connect some of these dots.
Yeah. So one of the things I was thinking about, I'd mentioned, how dark matter doesn't leave a trace and passes through material, but it's so plentiful that it made sense to me that an interstellar civilization would use it as a fuel. So that's the connection. Yeah. So that's the first connection I made in my mind with my own research. But there's another one that may interest you, especially with your interest and passion about the scientific method and philosophy of science, is that I was disturbed to learn only a couple of years ago that in some fields of science, my field is considered the crazy crackpot one. When, it's so funny because I thought, that I was part of the dogma, of like there's dark matter. And I was shocked to learn that in many other fields, like the other physicists and also other scientists are like, oh, dark matter, whatever. We just don't understand gravity. And God, that's one of my pet peeves. We just don't understand gravity. There are lots of things we don't understand. We still don't understand what time is. That doesn't stop us from building clocks and watches or understanding time dilation. So just because we don't fully understand something doesn't mean we don't understand it well. And so, but what I discovered is there was even internally, unbeknownst to me for years of working in the field, is that in other fields, it was already, dark matter was considered a crazy idea with no evidence. And I thought, well, you know what? If I'm going to be in trouble for working on something with no evidence, might as well actually make it even more worthwhile by doing UAPs, where legitimately is very hard and still on the fringes of science. At least there, the criticism might be warranted, versus dark matter shouldn't be criticism, because should be much better established. So that's part of my personal journey. Now, in your example with the metamaterials, so that's actually dark energy. But I like to think about everything. I like to try to broaden myself, not just focus on my research. And dark energy is kind of a different kettle of fish, despite sharing the name dark. But there is a theory where dark energy is more like dark matter, is particle-like. And I was looking at some of these claims online by people who wouldn't know this, and really wouldn't know, I think, these obscure details of this obscure hypothesis on what dark energy is, this chameleon hypothesis. And then I was looking at these claims of having physical material that have been alleged from crashed UAPs and things like that. There were alleged features of these materials that seemed too much of a coincidence to me, that they did seem to bear some relation to what could potentially be real physics.
Yeah, I'm going to share this slide that was from your talk about the, so some of these things that one of the slides that you showed in terms of the different, and so just a little bit of the context of metamaterials. So apparently there's, we may or may not have crashed UAPs. And from that, there's a lot of materials that may or may not be exotic. At this point, there hasn't been any peer-reviewed evidence that for sure shows that there's any exotic material that was definitely not made here on Earth. Now, I know that Jacques Vallée and Gary Nolan have been in the process of taking some of these materials and going through the peer review process and seeing if there's either one of two things, like a balance of isotopes that are exotic. So there's isotopes that, you know, are in the metals and everything. And if it has a certain ratio that you expect that all metals do, otherwise you have sort of potential either ways of engineering those isotopes or those isotopes coming from somewhere other than the Earth. The other thing is that the way that it's manufactured. So having such a small layer of, you know, layers of things kind of engineered at a nanoscale that is, I guess, beyond any technical capabilities that we have currently known, right? So there's a couple of things there that I know that Hal Puthoff was given a talk a couple of years ago where he was saying, well, maybe these are waveguides where they're taking energy and they're able to sort of focus it in a very specific way, and that maybe this is a part of how they're able to do what we kind of perceive as anti-gravity. But I think there's a number of questions of these UAPs, which is like, if they do exist, then what is the energy? How do they move? How do they do what they do? And so there's, I think Hal's approach may be taking stuff like the Casimir effect or 0-point energy, and maybe there's a way to scale that up. Maybe there's exotic mass that these things have, that they're able to kind of bend space-time in a very specific way. But I guess what you're presenting at the conference was, well, maybe it is these chameleon particles or dark energy that these craft have figured out how to harness them and sort of tap into this theoretical. We don't have any evidence of dark energy, so maybe this is some evidence of if entities are doing this. But you were saying, well, maybe this is an overlap between dark energy and how these craft are able to actually fuel themselves.
Yeah, so I was trying to take things a step further, thinking outside the box in terms of because metamaterials, that word is thrown around a lot, but it's off. But the real life metamaterials that we have as humans, therefore focusing photons in particular, particles of light. And I took Hal's waveguide suggestion and thought, what if it's a waveguide for something other than photons, something more interesting, more exotic, like dark matter, or in this case, dark energy? Because I thought to myself, as I mentioned, in my talk, if I were an advanced civilization, why wouldn't I find a way to tap in to 95% of the universe? Dark energy and dark matter collectively make up, we think, 95% of the mass energy density universe. To me, that sounds like, hey, that's free fuel for something, right? For which sitting around the entire universe. And so I did a very simple calculation, which I have to stress, it could be a coincidence, because we have more evidence that dark energy is actually what is called 0-point energy. There's a lot more evidence that that's the explanation. But if we say that dark energy is instead this alternative hypothesis called the chameleon particle, I did a very simplistic calculation where you can take an energy, and it's on the slide here. You can use Planck's constant h, speed of light c, and the characteristic energy, capital Greek Greek letter lambda here and come up with a characteristic length scale. And when you compare this length scale to the alleged properties of these alleged metamaterials that we may or may not have, right, that Hal Puthoff may or may not have in a safe somewhere, that it seemed to match to me. And it seemed to corroborate Hal's hypothesis of a waveguide. And obviously there's a lot of unknowns and a lot of intellectual leaps there, but I wanted to start thinking outside the box of that if these are actually interstellar craft, at least some fraction, that they use something completely beyond what we currently use for propulsion, power, things like that.
Okay, yeah, thanks for sharing that. So I heard about Hal did a talk a number of different years ago where he kind of elaborated that. And then I know Stephen Bassett did a transcript of that talk and put it out. How did you come across Hal's theory of the waveguides?
It's all thanks to this scientific coalition for UAP Studies, SCU, that was founded by Rich Hoffman. It enabled people like me and Kevin to make connections with people like Hal Puthoff and Eric Davis, who are really ostracized by the scientific community. And if you read the internet, you'll think, oh, rightly so, they're crackpots. And the more I've interacted with Hal at like conferences like this, and also one of his close collaborators, Eric Davis, the more convinced I am they're not crackpots and they've got really good ideas on potentially new breakthrough technologies. I don't think they're crazy, and I think they have some sound principles, but they do have peer review publications, not that many. I think part of it is because classification by the government, right? They work for the government. But the second aspect is the stigma. This goes back to your thing about the materials. We have, Jacques Vallée says, and others say they have pieces. So that's physical evidence. Do you know how hard that is to get through? Let's say you had a paper you trying to get through peer review. It would be tossed out by almost every journal in the world because they wouldn't bother. Again, it's like Galileo and the telescope. They wouldn't even bother looking at the evidence. Oh, you've proved you have crashed alien spacecraft parts. Yeah, right. And they wouldn't even bother looking at the plots and the data and the tables. They would dismiss it out of hand. And I don't want to dismiss it. If we actually have physical evidence, that's better for me than video and camera and FLIR and eyewitness testimony. God, if we actually have physical evidence, we should be putting that through the ringer but getting that into peer review papers. And like I said, twofold problem: highly classified and stigma. So that even if it's not classified, you'll never get it into a journal. Hopefully that's changing now because the culture is changing, it seems, slowly. But that's my concern, is you could have a great discovery and every journal would just go, la, 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 I'm not listening, because if it's too crazy, they won't give you the time of day.
Yeah, I'm so glad that I went to the SCU, because there have been papers that have been published, but it's in like the Journal of British Interplanetary Society. I have no idea, some of these, how that journal, what is that journal and how's that relative to the rest of the journals that are out there? Because I have trouble sometimes when things get peer reviewed as to whether or not it's, because there's peer review journals about parapsychology and other psychic phenomena. So just because it's peer reviewed doesn't mean it's, seen in the same scale as some of these other journals. So what is the JBIS?
So yeah, I did look it up after learning of Eric's work. It does not have a very high impact factor. So some would say that means it's not held in very high esteem. But again, part of the problem is the stigma. If I'm Hal or Eric and here's my, warp drive idea, and then the editor of the journal or the reviewer's the editor finds, Googles Eric and Hal and finds out, Hal also worked on remote viewing telepathy, they'll just go, they'll just gag and not even give them the time of day. So I don't want to jump to the conclusion that just because it's not a top-notch journal doesn't mean it's wrong, because I've actually become personally disillusioned with the peer review process in recent years. And I can speak about this openly now because, like I said, I've got tenure, so I can go neener. Like, I can speak to you openly that the peer review process is imperfect, and part of it is the stigma of your institution. University of Albany I'm very proud of, and I'm very proud of here. So but it's not Harvard or MIT. And so someone comes, someone's going to see my paper. This has personally hurt me. I've spent the last 3.5 years trying to publish with my colleague, Professor Cecilia Levy, a discovery that no one believes despite massive results. Simple discovery, nothing, not that earth shattering. We just demonstrated that radiation can freeze water sometimes. Interesting to me. Very interesting. Could be used as a dark matter detector. Oh, journal after journal is like, oh, it's crap. It doesn't smell right. And it's like, we've got plots proving the result. Like, what the hell is your problem? And so what I've learned is the peer review process is highly biased. If you don't have comma Harvard or comma MIT after your name or comma Yale after your name, goodbye. And so I've suffered with this with my colleagues to see that, because we're University at Albany, which, like I said, up and coming university. And I'm proud to be here. I'm proud of my colleagues in my department, but we are mistreated. And another aspect is, fortunately, I don't have to deal with this, but my colleagues do. I'm a white male, so I don't have this. Racism, sexism. You see female name as the first author. Oh, crap. Paper must be crap because woman physicist. And this happens and no one will admit it. And sometimes it's subconscious, right? We've been learning in psychology, subconscious bias is a real thing, right? And so this has really changed my mind on the peer review process. We need a peer review system, don't get me wrong, but it's very broken. Because if you know someone who knows someone, or you're at the right university and you're famous, you could come up with your BS theory of everything and it'll get published instantly if you're famous. But if you're not famous, you could have 100 pages of evidence your idea is right, and all the big journals would be like, nope, garbage, science, nature, they'll toss it out. And so I've been disabused of the notion through the hard knocks of life the last few years. I've been disabused of the notion that the peer review system is perfect. I've discovered it is broken. You don't get me wrong, you can't remove it, because then you've got every crackpot publishing their Einstein is wrong theory nonsense. So don't get me wrong, we have to have peer review in science. It is an important staple of science. And I don't know how to fix the system. I'm just stating that there are problems. There are some solutions, such as double-blind reviews. There are some solutions, but I'm telling you that I've been increasingly impressed by Eric's work and Hal's work, despite everyone else writing them off as crackpots, and despite their work being published in not the best journals, because I think that's not always their fault.
Yeah, and I think this is where I go back to Thomas Kuhn and his book, The Structure of Scientific Revolutions, where he really maps out the sociological dimension of all the scientific process, where there are these mainstream paradigms that come in terms of like the consensus, and that there's things that are on the fringe or the frontier, or the anomalous data that are coming in, and maybe people that are seeing that there's needs to have a model, alternative paradigms or alternative models that go against the mainstream paradigm, and that there's this sort of rhetoric of the difference between everything that's in the mainstream is science and everything that's outside is the pseudoscience. But I don't like that as a framing, because I think it's more of an evolutionary process of frontier science, or on the edge of like it is on the fringes, but it doesn't mean it's less. There's more possibility for it to be not end up to be correct. But there are sometimes that things have to start on the frontier before they get accepted by the mainstream, and so you have to kind of go through that momentum building process. And so what I see here is that there's this process by which that the US government is actually standing up and saying, actually, we have data. Like, this has not been something that, even though it has been delegitimized, this UAP and UFO phenomena for over 70 years, that there's actually enough evidence to warrant some potential paradigm shifts. And given that, then we're going to start to, have the scientific community be more engaged in something that, has up to this point been maybe a closed mind of saying this is impossible. So we're not going to entertain anything that sort of violates or goes against what these existing mainstream paradigms of our understanding, which are, again, these models that are in flux, and there may be assumptions that are changed with different things that come up. So I see it as part of the natural scientific process that Kuhn start to map out with the Structure of Scientific Revolutions.
I think I may have read Kuhn, but it was many years ago, so I don't know if this will jive with his thinking in his work. But the way I like to think about it is that, yeah, there is a fringe, like you said, and you got pseudoscience and science on one side. But I feel like when more data and evidence is gathered, things migrate one way or the other. Either it's proven and moves into science, or disproven moves into pseudoscience. Here's a great example of that. I made a lot of students angry in astronomy class this last semester. I'm like, astrology is bunk, and here's why. And I show all the studies where horoscopes are complete nonsense. You know, give the horoscope of a serial killer. Oh, the students get so angry because of me, you know, attacking their belief system sometimes. And the thing is so some things you take data, oh, look, it's wrong, moves into pseudoscience. But some things you take data, moves into science because it's right. I gave examples earlier, germs, atoms, theory of relativity. There are things that start on the fringe, but migrate the other way because the data gets collected. And like you were saying earlier, how can you collect the data if it's stigmatized or classified or both? And so the UAP, why is it still on the fringe and hasn't fully, like, you know, we haven't figured out fully. Well, I know skeptics will say, oh yeah, it's definitely a pseudoscience, as Wikipedia says, right? But basically, I think UAPs are in the gray or yellow zone because we're not getting the data we need to push it in fully into pseudoscience and write it off forever, or bring it into science and finally get the hard data. So it's kind of wiggling around there in the fringe. And the problem is, yeah, the data has to come down to help push it one way or the other. That's how I think about it, kind of like a Venn diagram where there's this tiny overlap region of fringe and things keep moving. Either they get cast off or they get captured into science.
Yeah. Well, I wanted to dive into a little bit of some of the physics stuff that Hal was showing, and just get your take on it. And because, like you said, some of the stuff that has been published in the Journal of British Interplanetary Society, it's sort of like, is this plausible? Is this, you know, like, because there's a certain level of theoretical physics. And maybe you could start, I'll ask you this, because it sounds like you're an experimental physicist rather than a theoretical physicist.
I build things.
Maybe you could sort of explain the difference between, you know, these two different communities, because they are quite different.
Yes, thank you for asking that question, because when most people learn I'm a physicist, they go, oh, so you're a theoretical physicist? And I go, no. And then look of confusion falls on the face like a party. Yeah, so a theoretical physicist versus experimental physicist. Lots of different fields of physics have this dichotomy. Not all, but many have this dichotomy. Not all, because you're not going to find, you know, an experimental string theorist. There's no such thing. But many fields of physics do have this dichotomy, which I think has advantages and disadvantages. But for whatever reason, you know, through the history of the 20th century, this dichotomy has cropped up. And so an experimental physicist is more like an engineer, and a theoretical physicist is more like a mathematician. And that's very crude. And I know I'll get a lot of criticism for saying this, but that's just my very crude way of explaining it in a simple way. It's a spectrum, of course, but there is definitely a pretty hard dichotomy. And it doesn't mean I don't look at any theory and I don't know any math. Of course not, because I have to use computers and equations to analyze my data, to write simulations of my data. So I don't just build things with wrenches and screwdrivers. Most of my work is also computational and is, in that sense, sort of theoretical. But the way a theoretical physicist approaches things is they look at the foundations of physics and try to look at the big picture questions. So in my field, for example, someone who does dark matter theoretically will try to figure out, what is dark matter? Is it supersymmetry, Kaluza-Klein? Is it an axion? Is it a WIMP? That is beyond my purview. I can dabble in it a little bit and I could understand and read a paper. Might get lost in the math sometimes though. But as experimentalists, to first order, I don't care what dark matter is. I just want to find it. I just want to find something that doesn't match the standard model. And then the way I look at it is like, okay, and then I'll make the discovery and the theorists can worry about figuring it out. There's also a gray area, it's my field, of people called phenomenologists, who I immensely, you know, respect, who are theorists, but try to get closer to the experiment. Like a phenomenologist isn't going to go, you know, turn a screwdriver, but they will try to get closer to the experiments, be less, pie in the sky, and get closer to the ground. So I hope that answer your question. Sorry about that.
I know you mentioned that you're an experimental physicist, and some of the stuff that, like, Hal, I'd say is probably more of a theoretical physicist, because and probably Dr. Eric Davis, although they may actually be, they probably do both actually, because Hal's been inventing different stuff and engineering stuff, and his whole theories on space-time and metric engineering. So taking an engineering approach. My personal background's in electrical engineering. I have an electrical engineering degree from Rose-Hulman. And so I understand the kind of dialectic between the theory of what the math says versus from an engineering perspective, you have to make all these different trade-offs between what you can and cannot do and what you can and cannot measure, and how to,
Yes.
stress test, because there's still trying to match up the different aspects of the large and the small in physics in terms of how does the quantum realm match with the general relativistic realm. And with your work, it sounds like you're dealing more with the general relativistic scale, but also maybe some of the quantum scale. So I don't know if your work, are you doing both the quantum realm and also the sort of general relativistic realm?
Yeah, that's a great question. No, my realm is mostly the world of the small, even though everything's interconnected. And that's because if we're in the search for dark matter, we think it's probably, a particle. And so then we're talking more of the quantum realm. That being said, I'm not completely disconnected from the GR realm, because it's thanks to GR that we think dark matter exists in the first place, because it's our observations in astronomy from outer space, from astronomy, astrophysics, cosmology, are incompatible with seem to be incompatible with GR unless you throw in this extra mass. And so there is a tenuous connection. So even though I'm not a theoretical physicist, I am well versed in the evidence of dark matter, and that's all connected to gravity. So even though I'm not a theoretical physicist, I still have enough familiarity with general relativity, gravity, because it motivates the quantum aspects and the atomic molecular, like small scale stuff of looking for dark matter as a particle hitting atoms. So I like to think of it as there's a deep connection. I think of myself as an astroparticle physicist, as interdisciplinary. And that's what my field's called, astroparticle physics. And search for dark matter falls in that umbrella. And it's a connection of the world of the very big with the world of the very small. You really can't divorce them, because they are interconnected. I am more on the particle side, but I don't neglect reading up and understanding my colleagues' work on the astronomy side.
Okay, yeah. Well, I think the interesting thing about the UAP, the physics of that, is that it actually does kind of also, just like the work that you're doing in dark matter and potentially dark energy, that it is kind of going from the quantum scale with the Casimir effect and 0-point energy all the way up to stuff that's, the Alcubierre Warp Drives and General Relativity and space-time metric engineering. But I want to dive into just some slides and get your comments on some of this, because I know that Hal has been talking about some of this stuff. And actually, if you go back to the very first To the Stars Academy press conference, you'll see some of the equations that end up the very same paper that Hal this weekend was talking about at this conference, the SCU, which is funny because it's sort of like that's my frustration. I've seen these like equations in math, and it's like, here's like people hearing scientists say, oh, it's impossible. And I'm like, what about these equations? And so I kind of wanted to get like a physicist's take on some of these different things. So I'm going to like just go back and to share some of these different things. So again, so Hal Puthoff, this is, he's introduced, and then Tom DeLong is basically, showing this as a slide, which is from one of Hal's papers. This is an Alcubierre drive, a sort of warping space-time metric that I'll ask you about here in a second. But so these are the close-up of some of these equations and whatnot, which is different ways of kind of looking at the general relativity. This is the details. So this is from Hal's paper that was published in the Journal of British Interplanetary Society in 2010, which apparently when you listen to Hal, this is a part of the BAS working with both OSAP and ATIP to be able to do these 38 DIRDs, these defense intelligence research papers. And that this was a part of that. And then they were afforded to be able to actually publish some of these things in open literature. And so Hal was going out, he was gathering all these different scientists to do these different research projects. I'm not sure if they didn't always know what the real reason is that they were studying UFOs, it said, but this happened to be the one that he did. I think that may have been connected to that and included in there. So he's coming with all this, but it's sort of referencing this earlier paper from 1994, Alcubierre, the warp drive, hyperfast travel. What's that?
I think that's the seminal one. That's the original. Yeah. That's the original Miguel Alcubierre, the famous original paper.
Yeah, so this is the original paper, the warp drive, hyperfast travel within general relativity from 1994. And then you have this little graph here, which I think is interesting just in terms of, and in the paper, it says that if you have exotic, exotic matter would be needed as well as negative energy density. So essentially the idea is that you have space-time, but then if you take certain aspects of that equation, you can actually warp space-time and then potentially experience some of these what he was saying, faster than light travel from an observer outside of that, but from their perspective, they wouldn't be. So it's a sort of a general relativistic sort of semantic trick in some ways that, you know, looks like they're going faster than light, but they're actually not. But they're able to warp the space-time, which, you know, if you look at these objects that look like they're floating in the air, then it could be that they're actually warping space-time, which I know Lou Elizondo has talked about, as well as Hal has been put forth this kind of theory. So with that, I'm curious to hear your take on the Alcubierre drive and the, you know, the feasibility of something like this happening.
I have a lot of thoughts on it. Yeah, good and bad. When there was a little kid, I was a little kid when the original paper came out. I have to say this is very exciting. Even though what I said originally about you don't need faster than light, I do have to say that it's always captured my imagination. Remember, I grew up watching Star Trek, and I thought that Miguel Alcubierre came up with a way to do this potentially for real, and what we see in fiction on Star Trek. So there are huge caveats, though. But you have to remember that was 1994. So Hal, Eric, as well as a bunch of other people, many of whom are not at all stigmatized, ostracized. There's constantly papers about FTL. So Alcubierre was first, but many, many other physicists, not just Hal and not just Eric, have taken the ball further down the field now. There's literally hundreds, probably thousands of papers on this. And so Alcubierre was the beginning, but it's only the beginning, and it had a lot of issues. It didn't actually work, but now it might actually work because we've been chipping away at all of the problems, like, oh, that equation doesn't quite work, but actually if you change this term, it does. So we've been chipping away at it. So the basic principle there is very sound. And I think Star Trek got it right by accident in the name. I don't know the whole history why it's called Warp Drive, because warp is a very appropriate name, because the idea here is that space itself is not limited to the speed of light. And that's a known thing from cosmology. Universe can expand faster than light, and it blows people's minds. But that's a known fact, that space is not limited to traveling the speed of light. Space itself, the fabric of space itself is not just some abstract mathematical tool. In general relativity, space, more correctly, space-time as one entity, in some way has an ontological existence. You can warp it, right? You can do things with it. And so it is true that space can move faster than the speed of light. No paradigm shift needed, even no change in our thinking of physics. But still, someone needs to go and figure it out, right? So Miguel Alcubierre was the first one so in general relativity, in what's called the Einstein equation, which is more famous among physicists than E equals mc squared. I'm not talking about E equals mc squared. I'm talking about the Einstein equation, where you have the energy mass tensor is equal to the is space and time warping. And so basically energy and mass warp space and time warp energy and mass. So what has happened over the past few decades, and Alcubierre, Miguel Alcubierre is part of this, is the ability to go back and forth both directions. So in other words, we can use not just theoretical calculations, and sometimes we need computers to help us. We can go both directions. We can ask, I want this space-time, warp drive, for example, time machine, for example. You can ask the question, I want this awesome thing. Then you can reverse engineer the Einstein equation and say, what mass and energy configuration gives that to me? So here's a trivial example, is, the Earth or the sun or a black hole makes a dent, would make a dent in that picture. And that's true. That's easy to go both ways. We had the Schwarzschild solution originally, and then we had more and more advanced ones for finite masses. And so the idea is you can use the Einstein equation to ask, I want to do this. What configuration of matter and energy gives me that? And so that's the one catch in Miguel Alcubierre's original work, is that you look deeply at it and it looks like it needs negative mass. We originally at least didn't know how to make that work. There are, though, possible workarounds, because there might be things like dark energy, virtual particles, 0-point energy. There are potentially sources of this negative mass energy density you need. But the trick is, so here's why you're asking me about feasibility, right? Here's why I'm not entirely convinced, but I need to reread. I need to look at this paper by Hal and also by Eric, because remember, I'm experimentalist, not theorist. I also have to look and get some help from my colleagues in theory. But I don't know how we're gonna bridge the gap of collecting enough negative energy, even if it exists, but I think only for fractions of a second, as far as my knowledge, is how we're going to harness that. So that is the hang up still, is how do you harness like the amount of material you would need to warp space-time in the way required.
Yeah, I know that just from listening to Hal, there is different aspects of some of the other papers. We're talking about the 0-point energy and the Casimir effect. And in your talk, you mentioned a little bit about the Casimir effect. And there's been, I think the 0-point energy is one of these things where it's, again, sort of in this realm that is speculative and, in some circles considered to be pseudoscience. But what you said was that the Casimir effect is real, but it just happens at very small time scales and very small, actual physical scales. To actually extend it and also scale it up is something that is more speculative, and that you don't know of anything that's in the open literature that has done that, but it could be existing in the classified literature. But curious to hear a little bit more about the Casimir effect.
Well, no, I have to correct you. Actually, 0-point energy, I mentioned in this talk, it's not pseudoscience. I don't know if anyone thinks of it that way anymore. It has been established over decades. It's very well established. What's not established is how to turn it into anything useful, practical. That is where it starts to get into the fringe. But I have to tell you, 0-point energy is 100% a thing. We've got, I mentioned in my talk, the Lamb shift, the Casimir effect, the fact that so in the Casimir effect, you can get an attractive force between two metal plates even in a vacuum, even when you account for the interatomic forces, things like that. And that comes from virtual particle antiparticle pairs popping in and out of existence. The controversy in physics still is 0-point energy just a mathematical tool, or is it ontological? You know what I mean? Like, is it real in some philosophical sense of word? And so there's the crux. But no one that I know of in this mainstream science community would ever call 0-point energy pseudoscience, because it's been measured repeatedly. Not only Lamb shift, Casimir effect, but most people think dark energy, discovered in the late 90s, a Nobel Prize winning discovery. Most people think the cosmological dark energy is identical. It's the same 0-point energy that you have on your desk when you do a Casimir effect in the lab at tabletop. That is the prevailing hypothesis. But where things go into the fringe is, okay, how do I capitalize on this? Tiny amounts of energy, tiny fractions of a second. And that's my hang up, where it's kind of like, to quote Fox Mulder, right, from the X-Files, I want to believe. I would love it if faster than light, if a warp drive was possible, like I said, I grew up watching Star Trek. I would love nothing more for this to work. I don't see how we're going to overcome the engineering challenges. So we don't even need a paradigm shift of physics. I don't see how, in our lifetimes at least, how to overcome these intense engineering challenges, because you're not just going to throw a Casimir plate or something on a box and go, all right, warp drive, go. Like this is really, really hard. But I've become increasingly convinced that Hal and also his close colleague, collaborator Eric Davis, especially, do have good ideas on how to address the engineering challenges slowly and move us forward.
Great. Yeah. And I wanted to share a couple of slides that Hal had talked about and get your take on some of this, because,
Sure.
There was, so this paper that, goes back to the paper that Hal was sharing here, the advanced space propulsion based on the vacuum time. So space-time metric engineering. So taking an engineering approach to general relativity. So some of the DIRDs he mentioned and called out, the space-time metric engineering was one of those that was included in that. And he's saying, and this is one of the slides from Eric Davis, or one of the slides from Hal Puthoff's talk, where he's talking about, like, just like with Maxwell's equations, you have electromagnetism. With Einstein's equations, you have the space-time metric, and then you can engineer the space-time metric for interstellar flight. That's the claim, that it's sort of from in the realm of theoretical physics that he's trying to prove out. But he has this thing here in terms of what was very interesting, where on one hand they're looking at sort of the secret backstory is that some of this research and motivation could be observed effects of what they're observing from watching UAP. So seeing different blue shift increases and different time dilation impacts and different ways in which that there's different aspects of the equation of general relativity. And when you start to do a space-time metric engineering of either some sort of exotic mass or energy density, just something that is outside of what we normally can see, we see these more exotic effects here in terms of this is what the equation would say and this is what you would expect, and that they're trying to make a hypothesis of, given that this is a theory, this is what the theory would predict, and this is what we're observing. So I'd be curious to hear if you have any sort of reflections on some of these different equations and some of these different expected effects that Hal Puthoff was talking about here.
Yeah, I think that, like I said, I think the equations are sound. Where I get hung up is how the heck do you actually do this? Because yeah, going back to our earlier discussion of dichotomy, you're right that this is moving like, thinking about this from an engineering perspective, right? Another way of looking at this is that general relativity, which used to only be theoretical, right? Talking about black holes, stuff like that. General relativity is moving from just theoretical GR to experimental GR is now a thing, right? We've got LIGO detecting gravitational waves. So experimental GR is now a thing. And there's also, I don't know if you're familiar with Ron Mallett, who wants to build a time machine by engineering space-time metric with lasers. Like, this is a thing now. Experimental GR is a thing. It's budding, though. It's a budding field, I would say, still. At least the tabletop version. LIGO is not budding. It's been around for it took decades to build. But the thing is, we don't really know yet the way, maybe Hal and Eric do, maybe it's classified. I don't see myself how we can make the leap yet to make this practical. Like, this is going to be hard. I'll tell you this. This is going to anger, I know, a lot of people, including people at the conference, but you're not going to go warp space-time in your garage. Okay. That's not happening. Like, this is going to be difficult, and it's going to require a lot of know-how. Like, we're talking, if this works, like I said, the theory appears sound to me, because it's based on the sound foundation of Miguel Alcubierre and people, and remember that paper is 1994. So Hal is basing this stuff on sound foundations, but where I have to be skeptical, not debunker, just healthy skepticism, is how the hell we're going to make this practical. And I want to believe, like I said, because belief is not enough for me. I'm a scientist. I would like to be convinced by Eric and by Hal. And I really do, because like I said, I grew up watching Star Trek. I would love it if warp drive was a real thing. Aliens already have it, and we catch up. That would bring me untold joy if warp drive was real. But I just don't see the missing gap here is how do we actually do this engineering? Because in order to engineer the space-time metric, you need to collect, for all the interesting stuff, positive mass isn't going to cut it. You need negative mass. You can't just go to the store and get some negative mass, right? That would be great for losing weight, right? But yeah, negative mass, anti-gravity, these are all things that if they exist, they do so for tiny fractions of a second and on very small scales, like these dark energy, 0-point energy. They're not pseudoscience, but they just we don't have like a Casimir plate extractor, you know what I mean? Like, we don't know how to extract a usable amount of energy. So I'm not sure how to make that leap, but I'm open to the possibility that there are civilizations who figured it out. And I'm open to the possibility that Hal has figured it out and can't tell us yet. I'm open to that possibility. I'm not going to dismiss it out of hand, because his equations are not the equations of a crackpot. Here are two ways you can tell a crackpot. And my colleagues will disagree with me. They'll say there are different ways or whatever. I have two rules of thumb. No math. Here's my theory of everything, of the quantum consciousness, blah, blah, blah. No equations. Two, Einstein was wrong. Soon as someone says Einstein was wrong, crackpot, because remember what I said earlier here? It's too late for Einstein to be wrong. Your GPS and your laptop wouldn't work. So those are immediately, as soon as they see, but Hal is starting with Einstein was correct, and he's starting with correct equations. That doesn't prove he's right. I'm just saying it diminishes the probability that it's wrong. Very subtle difference there. Yeah.
Yeah, I wanted to just share the other slide here that Hal showed. So he showed this slide that we showed, and then there's this also where maybe you could just like describe. Like, these are basically the same here. One's engineered, and one. I'm not quite sure what the exact differences between these two slides, but I think some of these may be the effects. But what are we seeing here in terms of what assumptions are this in terms of what is happening into the general relativity when you sort of tweak something or another? You're seeing these effects, but what is it that actually is shifting here?
So yeah, so the most important thing to see here, the most exciting thing is effective VL greater than C. So on the first line here is sort of the sexiest, because it's saying, okay, you can go faster than light, sort of, right? The trick here is that it's the space-time fabric that's moving faster than light, not your ship, right? It's like the classic analogy that was used to explain Star Trek is like whipping up the carpet, right? But then the catch is that you go to the last line here and you look at the last line, which says gravity force, and it says repulsive gravity force. And that goes back, this negative mass energy I was telling you about, and we don't know how to get enough negative mass energy to make this practical, because how would you gather it? And the other thing is how would you start? Like, this all works if, let's say, a warp tube existed from the beginning of time. Like, how do you start this effect and how do you stop it? How do you put the brakes on your spacecraft? Now, those are the big criticisms. I do know that Eric has told me those are solvable criticisms. Hal's collaborator Eric, and like I said, I'm open to that possibility that those are solvable problems. But those are like the big problems here. Is all these things are like effects. All these equations apply to you're already moving faster than light. You know what I mean? But nowhere here does explain yet. How do you get up to that speed? How do you start from smaller than the speed of light and go past it? And that has not yet answered to my satisfaction and to many of my colleagues. And I know if Eric was here, he'd be like, no, Matthew, go read my paper again. It's all solved. But like, the thing is yeah, I'm not fully convinced that we can go from less than to greater than C. Not with these equations alone. So these equations are applicable if you're already traveling faster than the speed of light, then great. All these things are true. How do you get there though? To get there, you need a sufficient negative mass energy density. And how do we get that? I don't know. But that's a question of engineering. That's why I'm not dismissing it as impossible, because it doesn't really require a significant paradigm shift in physics. It does just require clever engineering. So Hal is right about that claim. Engineered. Engineering is the key word. We're not, I know you hate that phrase. We're not breaking any laws of physics here as we currently understand them. What the question here is how do we engineer this? How do we actually make these equations leap off the page and make something that actually works?
Yeah. No, that's really helpful. Thanks for that. And again, this is from the paper that I was referencing before, the advanced space propulsion based on vacuum space-time metric engineering, which...
I've looked at his paper, and like I said, I need to get a more informed opinion with some of my more theoretical colleagues, because maybe I'm wrong, and maybe the paper already solves all the problems I just said. I'm being humble here and honest that I don't understand enough to say definitively, oh yeah, this is wrong. And I admitted that. I said to Eric, who was at the conference, right, as an attendee, Eric Davis, who also wrote a paper in JBIS and works with Hal. I said, look, I was humble and honest that maybe I'm wrong, but I'm just telling you my opinion. But I think that I don't see that final step is how do you take this and make it happen? I would love, if they've solved it, then they deserve Nobel Prizes, right? Because then they discovered fast and light travel. Obviously, they need to win a Nobel Prize.
Yeah. Yeah. Well, again, there's a potential part of this that could be figured out, but is in the sort of classified realms. And but yeah, I think there's part of the spirit of why I wanted to get you together to get your take, because I'm sitting there watching Hal, and I'm like, I don't have enough of the background of this field to be able to make heads or tails and to know whether or not, what end of the spectrum, how feasible this is, and whether or not it's all been figured out. I come back to this process of science is this dialectical deliberative process where there's those who believe different potentials and those who are trying to avoid the falsehoods. And you need to have this dialectical collaboration between those two to be able to, in some ways, have empirical evidence to be able to match some of this stuff, because this is something that could have what Hal was, I think he was presenting this in the context of, we have observed phenomena with this UAP. Here's the physics equations that could explain some of the phenomena step by step that they could start to go through. Each of these different effects that, Hal was talking about, he could probably give a whole lecture on how that's justified in terms of how that's been in this observed phenomena, but with the data that is all in this classified realm. So he's had privileged access.
That's the key to me. So obviously we've not observed any craft traveling faster than the speed of light, but there is a predictable effect from a craft that would be using this. I think the same effect would happen even if you're not traveling faster than light. Even if you're warping space-time to go, but not necessarily go faster than light, but go, a few hundred miles an hour or something. There is this Doppler shift effect. And Hal mentioned this. It was in these slides. And if I saw a Doppler shift that was consistent with an Alcubierre drive, oh my God, That's awesome. We have to be careful though, right? Make sure it's not consistent with anything more mundane. But God, that would anger me so much if that data exists and is classified, which it probably is. What if there are craft out there that are using warp drives and we can prove it? Because they're not going faster than light, not in our, in our atmosphere, but they have the right Doppler shift that Hal was talking about. That would blow me away. So that's also why I'm on, why I'm on SCU and these things, working things with Kevin. I want to do an end round around all the secrecy nonsense, get my own data with Kevin and like-minded people. Let's get our own data with the cameras, spectrometers, everything. You heard the talks also on SkyHub, UFO DAP. Kevin and I are both interested in both of those technologies. The speakers are great people who presented on SkyHub, UFO DAP. See, there we go, serious science, right? Let's get the hard data. I would love it. It's like, oh, look, here, look at the energy spectrum. It's consistent with an Alcubierre drive. That would blow my mind. It would change my worldview forever. That would mean either they're alien or, I guess the Russians or the Chinese could have developed warp drive, which is like, wow, I don't know if that's better news or worse news if that was the explanation. But if there was someone flying around with an Alcubierre drive and we could prove it by looking at the Doppler shift, it's just mind blowing, because then it's no longer a question of is it possible or not? Well, you just saw it. Yeah, it's obviously, it's possible to get through the engineering hurdles. So, I stressed at the very beginning of our discussion, I think, remember that a lot of very smart individuals used to think air travel and space travel were impossible. That's why I'm open to this. I have a YouTube video about time travel that I give, because even though I think, yeah, it's probably impossible, I kind of leave the door open a little bit, because I think it's a little too arrogant to claim something is impossible, because we don't know everything yet, obviously. So I leave the door open a crack there. And similarly with this faster than light, I think there might be something here. And I would love to get hard data like that shows that there's an alien craft that uses Alcubierre. Oh my God. And again, though, it would be rejected by every peer-reviewed paper, journal. They'd be like, we're not going to review this. This is garbage. Even if it was incontrovertible, they would think it's garbage. But, in the era of internet, it's hard to suppress things. And so we would, slowly we can chip away, like you're saying, chip away and get a paradigm shift.
Yeah, well, as we start to wrap up here, in my normal podcast, I like to ask people like the ultimate potential of, immersive technologies. But I'm curious what you think, if it does turn out that this is a real thing, what do you think the most exalted outcome of all of this could be, from both a scientific perspective, but also for what it means to be human?
For what it means to be human would be changed forever. If there are non-human intelligences, religion, philosophy, everything's going to change. And not only in positive ways, it's going to be a mixture. If we've learned anything about human nature, we look at terrorism and racism and all these hatreds. I think that if like tomorrow there was a press conference and like Biden and Putin, some leaders of the world are like, hey, guess what, everybody? It's aliens. I think that there would be both positive and negative in my opinion. I could be completely wrong, but this is just my opinion, is that there'll be negative and positive, because first there'll be chaos and you'd have terrorists wanting to kill them because, oh, they're evil or demonic or something. You'd have religious extremism, you'd have this and that. There would be utter chaos. But I still think ultimately it would be a positive, because as a scientist, I think that truth is of immense importance. I despise suppression of truth. I despise twisting of truth. And I think that for better or worse, like I said, even though there'll be negative side effects, if we have hard data that we're dealing with some sort of non-human intelligence, whether it's, like I said, I do want to be open-minded. I don't want to pigeonhole us into, oh, it's extraterrestrial or interdimensional. I know they're the fancy acronyms, right? ETH and IDH, hypothesis stuff. What if it's a mixture? What if it's something else? What if it's something we don't have a word for, right?
Ultra-terrestrial is one that I hear a lot in terms of, if the isotope ratios of the metamaterials are from Earth, but they're exotically produced, that could mean, well, what if they're here natively?
Yeah. That's right. All these possibilities, any of those possibilities, that I'm trying to be as generic as possible. When I say non-human intelligence, I'm trying to be respectful of alternative suggestions. But any of them would just completely blow our minds. But I think that in the long run, I think it is a positive. I disagree with all the scientists who say, like the late Stephen Hawking, who I did greatly admire, of course, as a great scientist. But he said, oh, we better hope that more advanced aliens don't find us because we'll end up like the Native Americans. I hate this projection of human centrism, of what's the word? Anthropocentrism or
anthropomorphic sort of.
Anthropomorphism, yeah. So why wouldn't a culture more advanced with us necessarily be evil and crush us? I'm sorry, I don't subscribe to that. I'm more optimistic, and I think an advanced culture would not necessarily, we're not going to end up like the Aztecs with the Spaniards. I think that's a very pessimistic view, because I'm sorry, if you have enough technology to cross the stars, whether it's FTL or it's a more standard relativistic travel, really you're going to go all that distance to colonize or start a fight when you probably have a scarcity-free society and you have these amazing resources, you can do space-time metric engineering. Like, I know that many philosophers have written, moral development is not the same as technological, one can outpace the other. That's true. But I'm still optimistic that a society that advanced to have reached the Earth from outside the solar system, if that's the explanation, like I said, there may be others, I don't think that we should jump to the conclusion, like Stephen Hawking and many have, that it would be a horrific disaster. It would be like Europeans colonizing America and our culture will die and we'll all, no, I think there will be short-term suffering as humanity comes to terms with a non-human intelligence. And because, like I said, there'll be people who deny, even if it's, they're the aliens landing, on the White House lawn or the Kremlin or in different cities and around the planet, right? We think very US centric, but they could, who knows where they want to say hi first. So there would be immediately people would be like, I don't believe it. Special effects, Adobe Photoshop, on TV. So, and then there'd be the people who really don't care. They're like, oh, aliens are real. Oh, well. So then there'll be a fraction of people who don't care. But I think in the long run, it'll be so positive for humanity that in my opinion, the positives outweigh the negatives if we prove that non-human intelligence is real.
Great. Is there anything else that's left unsaid that you'd like to say to the broader scientific community?
Well, let me think. Yeah, I think we've covered a lot of ground today. But yeah, what I want to say is that there is something going on here. There cannot be, Navy pilots, police officers, and all the stories in 60s, 70s, regular people historically, ancient times, all the stories of unidentified flying objects throughout human history. Can they really all be crazy and wrong? That seems, I want to turn Occam's razor around on its head. To me, that's absurd. That all these people are just crazy. All the people who have seen ships, people who claim to have been abducted, all of them are wrong. They're all psychologically ill. And what about people who see the same thing at the same time? Oh, mass hysteria. Show me a psychology paper that proves two people can have the same hallucination at the same time. That's not a thing. I would love to be proven wrong. I don't think that's a thing. I think that's a thing people pull out of their butts to feel better about UAP. Like, oh, mass hysteria, blah, blah, blah. Really? Point me to one peer-reviewed psychology paper that proves more than one person can have an identical hallucination. Hallucinations are private to the human mind. I'm sorry, you cannot have identical hallucinations at the same time. So to me, the explanations against UAP have gotten dumber by the debunkers than just saying, oh, it's interesting. Again, I said interesting, not alien. It's something interesting, some non-human intelligence, be it alien, be it something else. Let's stop pretending that mass hysteria is real. There's no such thing. It's a fictional phenomenon. I'd love to be proven wrong. If you can find me, one of your listeners can send me to a paper, I'll read it in a psychology journal that proves empirically that two people or more can hallucinate the identical thing at the same time. I'd love to read it because I don't think it exists. So basically, I think that there's just so much has happened, not just in the 20th, 21st century, but looking at all of human history. We can't just dismiss everyone who's seen something strange in the sky as a misinterpretation of bird plane, etc. from modern times. We can't just dismiss all of it. There is, I think there's a tiny fraction there that truly is begging for explanation that requires some outside the box thinking beyond, bird, bat, plane, drone, etc. So that's the final thought that I would end on.
Okay, yeah, just to sort of follow on that is just that as I've listened to people like have looked into Blue Book and other things, they often hear that when they do an audit of all these different experiences, that there are a significant majority of them that are explainable by mundane phenomena, astronomical phenomena, whatever. But it's like a 5% that can't be explained, and it's those 5% of the 95%. So there may be two people that witness something, but that doesn't necessarily mean that it's exotic or
correct. Yes.
Violating some sort of our understanding of the laws of physics. But what I would say is that what we need are the data, because the data are from multiple sensors, multiple perspectives, and that's the thing with eyewitness testimony, with electro-optical data, radar data, data from satellites, data from stuff that is so classified we don't even know exists. Like all these things, seeing the same things and being able to verify it through those multiple perspectives of that data. That to me is the thing that is probably the most convincing in terms of the government, and would be for the larger society and for science if we had access to it. So I do agree that going back to what you had mentioned earlier, SkyHub and UFO DAP, these are different citizen-driven science to try to gather the data to be able to actually sort of take it out of just the control of the US government. But yeah, I just wanted to put that out there as a follow-on, and also just to thank you for joining me here on this little discussion, because after seeing you speak, I really wanted to sort of unpack some of these other aspects that we heard over the course of the weekend at the Scientific Coalition for UAP Studies. And I'm excited to where this all could go, and I feel like we're on the brink of things opening up, and like I said, it sort of all comes back down to having enough data for the larger community to be able to kind of push forward this knowledge. But I'm glad that there are people like you that are on the frontiers of willing to take the step out and think about these things, and also potentially provide some ideas of helping to explain what we're observing. So Matthew, I just want to thank you for joining me today, and for taking the time, and for doing a deep dive and geeking out about this for a little bit.
You're welcome. We're going to get that data one way or another. We're going to get that data. We're going to get some hard data on this, and we're going to figure out. I'm optimistic that within my lifetime, we're going to know what the phenomenon or UAP, whatever it is, or they are, if it's multiple things. I'm confident we're going to make some headway in my lifetime. I'm optimistic.
Awesome. Well, thank you so much.
You're welcome.